there is another protocol called WAP. Now this is confusing. We are not talking about WPA, that is Wi-Fi. Wi-Fi is done. Now we are talking about WAP. WAP protocol is totally different context, total context switch in your brain. Now we are talking about how to serve HTTP to mobile devices. So about 10 years ago, they started thinking about how can you do web on your phone, right? And the main problem they faced was that the web pages are so big and the mobile devices are so small. How to fit a page on a device. So they came up with this solution called WAP. So this solution is basically that the client, which in this case is a phone, sends a request which is captured by the gateway, which is called the WAP gateway, and this acts like a proxy, and then sends the request to the original server where the web page is. The web page doesn't know about mobile devices anything, so it sends a big response. Then this gateway understands the mobile device. It knows that your phone is a Samsung XYZ, and therefore it has only 3 lines and 5 characters each line or whatever. It knows all the phone devices. So it then makes the response suitable for your device. It's not an easy job, but they attempted that. So that's basically it. This is gateway is the WAP proxy. And so there is basically the best thing would be that you write your own page for each device, which you can have another difficulty. I mean, how can you write one for Samsung, one for iPhone, one for that, right? So that's impossible. Then the proxy is designed with that, but then pages are all different kinds. How can you fit something which is so big into 5 lines? So that's also not very easy. So WAP actually, according to me, and I didn't see that written down in this book anywhere, WAP really didn't succeed. And I'm still going to verify that whether it really exists or we are just teaching some theoretical work here, because it was done 10 years ago. It was done 10 years ago, and I remember 5 years ago or 6 years ago going to a meeting where they said WAP is a failure, and now we are thinking about WAP version 2, and so on and so forth. And I don't know what happened. So anyway, so this book sometimes actually is out of date, and this could be the case. For example, I am preparing the next lecture, chapter 18, and it says, in future we will see this thing, and that future was a 1999 RFC. So 10 years ago, they were talking about that RFC, which was this says internet draft. So 10 years ago, they wrote that sentence, in future, and in a book which is 2011. So sometimes, they forget to update it. Similarly, this WAP thing is, I'm teaching you because it is in the book, but I really don't know whether it exists in reality or not. Actually, this is more reliable, but I didn't see that here either, so that's why I prepared the whole lecture. So the best way to do is, nowadays people do it, in the sense that nowadays many websites are designed for iPhone and iPod. All right, you go to any newspaper, if they don't provide one for iPhone and iPod, they are not doing their job. In fact, I've been thinking if I get a minute, I will design my website for iPhone and iPod, because that's the only way people see the web these days, right? And so now there is some standardization coming in because of, and actually it's not really a standardization, but there is a majority. There's millions and billions of devices which have the same form factor, and then you get iPad and so on and so forth. So there is that kind of happening. So people are designing a special pages just for that. So that is one possibility. Okay, so if Google is using WAP, I take it. It is supporting phone that has WAP, that have WAP. Okay, well, that's a good news. That's a good news. That satisfies my curiosity, because when I couldn't find any such thing that it has been discontinued in this, I do remember IETF meeting, and that IETF meeting, if I remember the date right, was 98. 1998 IETF meeting, WAP people came, gave a presentation, and said that, there's a problem, this and that, and it's failure. So WAP 2 is what they were talking about in that year. Back to this. I think everything is said what is on this slide. Anything else? So we move on to the next one. So basically you have the server, you have a proxy, and you have these mobile devices. Now, only new box that we have added here is an HTML filter. Basically, this WAP proxy can understand only WML. Just like HTML, we have WML. WAP, what is M? M is for markup language. WAP markup language, if that is already built in your web server, then this will have easy time. Otherwise, this will have to somehow convert your HTML into that kind of format. So that's why you need this device. So now we have a new word here in this slide, and that is WML. WML is like HTML, but only for little phones. Second new word is binary WML. So WML and HTML are both ASCII. Every bit counts on the wireless. So they didn't want to send the bits that can be removed, and so they compacted it to a binary WML. If nothing else, you can just zip it and it becomes smaller by a factor of 2. So I really don't know what they do for binary WML, but that basically makes it smaller for transmission over the wireless. So here is WML. Describes the content format for devices with limited bandwidth. So this looks like very much like HTML, but you put this thing there, wapforum.org dtdwml.xml. So that gives you certain new codes such as cards and things like that. So WML, actually what you do is you put like a deck of cards, and each card is one screen full of the device. So you have this deck and the card, and you present them one card at a time, and each card looks like this. Card ID is main, title is first card, mode is wrap, and this is a sample WML page. So now if you write a web page like this, this is WAP compatible. Like that's what he's saying, that he wrote WAP compatible code for Google. But good thing is that if you put this is good win-win in the sense that it is not a lot of work for the web people, because we didn't put any device specific thing here. All we said was that wrap it. If the device cannot support this whole thing line, then wrap that line. And then these commands would supply for any phone, and all the details will go somewhere else, basically in the WAP proxy. And WAP, if you remember, is this system which allows wireless access to web pages. So normal web servers could be designed for WAP accessible, or they would not be designed. If they are not designed, then there is a filter required which somehow changes the big page into a small page. And so that is one. And then the proxy is here, because proxy further reduces these pages, which are, even though they are designed for wireless devices, to compress them, making them binary, and so more like a zip, and that way less number of bits are transmitted over the air. So the WAP proxy's job is to convert from ASCII with the WML. WML is the wireless and that WAP markup language, and so that converts WML to binary WML. And this filter's job is to convert a normal web page to WML. And nowadays most sites actually are basically designed for the WAP, in the sense that when you go to m dot something, so let's say Amazon.com is one page, right? But you go to m.amazon.com, that will be a site which will be suitable for just little screen. So the markup language, basically an XML based. So in any XML based language, you have to have a URL which tells where to get the information about that language. So this WML is described at this place, wapforum.org WML 1.1.xml. So when this page goes to any XML capable reader, which is what most of the browsers are, they will go here, and they probably have a cache of this anyway. They will use those definitions, and so that creates new definitions such as card ID, P mode, and other things. And Now the card, as you said, is that the WAP pages look like cards, a deck of cards, one behind the other, and so each of these is a card. So this is the beginning of a card, end of a card, and this is the beginning of the card. And then you can flip back and forth between the cards, which is similar to tabs, or you can have, if you can think about Windows even. But while on the computers, we don't really keep windows one behind the other, but when you do it on your mobile, even when you use Firefox or anything like that, generally you see those cards when they show you pages, 5, 7, 8 pages or something like that, they show you. So that's the whole idea of the cards. Describes contents, formats, and data display on the devices with limited bandwidth, screen size, and user input capability. So that is what WML is for. And so it can describe text and images, layout, just like HTML does, but it has a card metaphor, and then somehow there is a translation of that card to your device. But every device is different. Just like every display is different, every laptop is different, so that's not news. Basically, HTML is written so that you can render it on any display. Similarly, WML is written so that you can render it on any little display. That's all there is. So that's WML. Talking about security, WAP has quite a bit of framework here, but the key thing to notice is here, this column. So it has cryptographic libraries, authentication, identity, PKI, transport security, which is like SSL, and secure bearer. Bearer is the wireless part, the even below data link. All right, and the rest of it is the normal application. So there is nothing special here. But these are the things that are part of the WAP, and so it supplies all the security that is required for authentication and for encryption, and for actually, let's see, so authentication, user authentication, I'm just thinking whether there is a message authentication here anywhere. PKI, secure transport. So maybe part of the secure transport there might be message authentication. So this is user authentication, and then the secure transport, just like TLS, has both message authentication and message encryption. So all the libraries are supported, authentication, TLS is supported. So there is a new word here, WTLS. TLS we know is SSL, transport level security, and then WTLS is wireless version of that, and this is client authentication as opposed to message authentication. Identity is the WAP identity module stores user IDs and secrets. So that is user ID and user authentication. PKI everybody remembers is certificates. Secure transport is WTLS over datagrams. So there was so basically there are two other versions of TLS that we didn't talk about in this course. One is called DTLS. So the TLS works over TCP. DTLS is datagram TLS, and datagram means no connection. TCP requires a connection, so you have a kind of session or something, and then you get a key, and with that key you use it for the whole session. With datagrams there are no sessions, so you have to have per packet key.
So is it done over UDP then?
Yeah, this is over UDP, yeah. Datagram means UDP. And so DTLS is designed so that you can encrypt UDP packets. And there is one per packet key, and then how that packet key gets transformed or calculated at the other end, that I don't have the details here right now, but if you are interested you could find out DTLS. And similarly WTLS is basically another transformation of DTLS for wireless, so that the number of bits are reduced. Alright, secure bearer is basically what is underneath the transport. In this case it could be IP or IPsec. So service discovery is external functionality interface allows the application to discover what services are available on the device, okay, and provisioning to set up the parameters. find the new network services, and to service lookup is the services parameter using DNS. So basically the idea is that the WAP protocol also has some commands which are common to all the devices. So you can ask the device, what is the size of your screen? You can ask what protocols, and there are other things like what protocols you support and so on and so forth. So that is what is called service discovery, is that basically both ways things could be negotiated as to what your size is and what security parameters you need, and all of those things. So that is what is under service discovery. Then there is a WAP application environment, which is like a library of modules that can be used. So for everything that we have, like for example for their app, they use the library. So there are libraries for WAP. If you're writing a WAP application, then you can use those libraries, and they are like any other library. Basically, they have all the things that you need. So user agents, software modules for devices and displays, wireless telephony applications for telephony, and content encoding for web content, push to push the content, to send the messages over the air, and SMS, etc., etc. So for all of the functions that you might do on a mobile device, there is a library. Now in terms of protocol architecture, the device has these layers: WSP, WTP, WTLS, and WDP. WSP is session, TP is transport, TLS is, as you would expect, the security, and DP is the datagram protocol. Alright, so these are the 4 layers here, which are also in the gateway, WAP gateway, and the web server may not have any of this WAP stuff, so therefore the web server speaks the standard HTTP, TLS, TCP, and IP. So the gateway receives the standard stuff and translates it into the WAP. You can see the correspondence, and the strange is that basically bearer corresponds to IP, the TCP corresponds to WDP, which is the datagram protocol. TLS is this layer, and then HTTP, the application has both session and the transactions. The normal transport has been divided into 2 parts. One which so TCP actually is session layer as well. TCP has a session layer, that's why it has a connection. And but here that is part of this SP and TP here. Okay, so key thing to remember is that the WTP transaction protocol is not complete transport. It has some functionality of the transport, actually mostly for transactions, and basically it divides the transaction into 3 classes: class 0, 1, and 2, and with different levels of reliability. And so that's what this WTP does. It's not a transport protocol. The real transport protocol is WTP. WTLS, wireless transport layer security, it is based upon TLS, and the main difference is that the bits are very expensive, and therefore everything is compressed. The certificate format is compressed, the data structures are compressed, and rather than TCP stream, they use packets. So each packet has its own key and so on and so forth, and the gateway does the TLS to WTLS translation. Now there are 2 situations where the wireless may or may not be IP. So this is the situation here, is that the bearer here may be IP or may not be IP. In the old days it was not IP at all. In the old days IP was not used in the cell phone networks. IP was only used in the wired networks. Today there is a move to make bearer IP. So the telephone companies are adopting, and maybe in 4th generation it will be all IP, but in 2nd generation and 3rd generation this is not fully IP. That's why in particular you need WTLS, because WTLS does not require IP. Whereas TLS requires TCP and TCP requires IP. You cannot run TCP without IP, and you cannot run TLS without TCP. So this is designed so that it can run on anything including UDP, but it can run on any other protocol which is nothing to do with the TCP/IP protocol. Now WAP version 2. WAP version 2 is IP end-to-end and therefore TLS end-to-end. In WAP version 2, you don't need WTLS. Yeah, this is WAP version 2, WAP 2. I will go back to the previous slide, but in a minute. But basically, when there is IP end-to-end, then you don't need WTLS. Then you can just do straightforward HTTP, TLS, TCP/IP, even in the device. And then the gateway is trivial. Gateway is like a normal, basically, is normal. It just forwards the encrypted messages. It doesn't even have to decrypt. In the case of WAP 1, all the messages have to be decrypted and re-encrypted from TLS to WTLS. And in fact, it doesn't even have to do TCP. It could just do IP. The gateway could just do IP and then just like a normal router, which doesn't read TCP at all. All right, going back to this picture here. So everybody understands what is the need for WTLS. Two reasons. One is that the cell phone networks did not have IP. And since they did not have IP, they did not have TCP, and therefore they could not use TLS security. Second reason is just the bandwidth, throughput. The normal certificates are just too big for wireless. All right, now WTLS, just like TLS, if you remember, TLS had 4 protocols. So WTLS has 4 protocols: handshake, ciphertext, alert, and the record. Anybody remembers what is the function of the record protocol in TLS? Yeah, so that's the encryption protocol. This is the negotiation protocol, and this is the error messages, alerts, error messages, and this is nothing. This basically is change cipher spec is whatever you have negotiated, let's use that. Right, so those are the 4 components. Exactly same here. And notice that the WTLS runs on UDP IP or WDP, which is actually cell phone version of bearer. Now in terms of facilities, it uses RSA, ECC, and everything else is very similar to TLS and standard. MD5, SHA-1, DES, 3DES, RC5, everything else is standard. So we already saw this slide, both sides. This is when IP is end-to-end, then you have a choice of going to the transport layer or not going to the transport layer at all, and just acting like a normal router. And depends upon the content though. I mean, if the content has to be filtered or something like that, then maybe you will go through this way, get the content and change it over for the other side. WAP end-to-end security over WAP 2 end-to-end security over IP continued. So here's another thing is that basically the way it works is, WAP works is that you call your tower and that connects you to a WAP gateway and you get all your content through the WAP gateway. However, some companies may not trust the telephone company's WAP gateway. They don't want them to be decrypting their information or encrypting their information, particularly the hospitals and banks. So they will have their own WAP gateway. When they have their own gateway, basically you connect from here, but then they redirect you through that message that please connect through here. Once you connect through that, then you really get end-to-end security, which is not hampered by any cell phone stuff. So I mean, somebody can take responsibility. If something gets broken, then we know who to blame to, rather than cell phone companies knowing all the secrets and then somebody stealing it there. So there is no decryption. All right. So you understand the need for this picture. There are some situations where we don't want to use phone company's WAP gateway. In that case, we will use our own WAP gateway and tell the device to connect to our WAP gateway. So basically one thing which is not shown here is the tower. So in between here there is a tower, and so this WAP gateway sends the message to the tower and then goes to the phone system. Here this sends to the tower and goes to the phone system. So right now it is showing directly to the device, which really means going to the tower because there is no direct wire to the device. There is a tower there. Alright, so that brings us to the end of this wireless security. And then we talked about 3 different things actually. So basically in Wi-Fi we had 2 different standards. The WAP standard, first of all, what we did was we just defined what a Wi-Fi looks like. So a Wi-Fi LAN consists of BSAs and ESAs, extended service areas and basic service areas. And basically the difference between the two is that the many different BSAs will be connected by wired backbone, and that is called the distribution system. So you should know what is a BSA, what is a distribution system, what is an ESA. Then we went into security. The first standard was called WAP, which is wired equivalent privacy. And it used RC4 for encryption and CRC32 for MAC. And both of them were basically weak. And therefore they were trivial to break. So the new standard came out, which is called WPA2 or RSN. However, that requires hardware change, so therefore one more method was invented, which is WPA or TKIP. And so the TKIP provides 64-bit MAC rather than 32-bit CRC using, and then it uses the same RC4 though, with 128-bit key. But the packet is per packet key. So that's the thing, that's the difference. Is this per packet key where this is a shared key. In the case of WPA2 is hardware, and therefore we can use AES encryption, and that can be used for both authentication and encryption. Then we talked about cell phone world. In the cell phone world, we use WAP, and so the WAP had many layers like sessions, transactions, datagrams, and so on and so forth, those protocol layers. And then we talked about the WTLS, which is the wireless version of TLS. All right, let's see the homework. WAP assumed all devices in the network share a secret key. The purpose of the authentication scenario is for the STA to prove that it possesses the secret key. So as long as you have secret key, you are authenticated. As shown in the figure below, the STA sends a message to AP requesting the authentication. The AP issues a challenge. The ST issues a response, and the access, and then it says fine, you are successful. Now, first of all, there are three questions. This authentication is one-sided. So who is being authenticated here? And that you have to tell, yeah, there is only one side is being authenticated, and how can it be made mutual means you need to add some more messages afterwards to make it two-sided. Second is, what information does it provide to attacker, making it easy to attack? Now, remember this is RC4, so that's the thing, is that it is very easy to attack. Anybody can basically, without knowing the key, they can pass. This comes to RC4, how can attacker create a valid response challenge after just valid authentication? So you don't need to know the key, you can just get the valid response. So that's basically knowing about the RC4.